I don't think I ever anticipated 8K video. You really start to need the, better codecs in order to deliver good experiences. Part of the reason that it had to be two-way audio video is because we felt like the one-way world was really crowded. There are probably more people doing bidirectional communication on the internet than there were people on the internet in 2002. But if there aren't companies really using these new protocols for these use cases, then they're going to end up not really working.
I'm Matt, the organizer of the SF Video Technology Meetup and the Demuxed Conference.
And I'm Steve, creator of Video.js, the open source video player.
And I'm Phil, streaming specialist at Mux in London and organizer of the London Video Technology Meetup.
And you're listening to Demuxed, a podcast for and by engineers working with video.
Demuxed is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com.
We're always looking for topics, so if you have any suggestions or just want to tell us how wrong we are, you can find us on Twitter at Demuxed.
Hey everyone, welcome back to Demuxed. It's been a hot minute.
No.
I opened up Overcast to show somebody where we were, and we are listed technically as inactive on Overcast right now. So hopefully this bumps us back into activity. So anyway, thanks everybody for joining us today. We don't have Phil, so as we've done in the past, we replaced him with another person with a delightful accent to give us that culture,
Mm-hmm. We're international.
There you go. Not just a bunch of crass Yankees. So those of you that don't know Nick, he's a Demuxed speaker extraordinaire, thought leader in general in the video space.
Definitely.
Real-time video connoisseur.
And I'm kind of feeling a little intimidated today because I have previously given talks on RTMP and now I'm regretting it.
And our guest of honor today is Sarah Allen from Veriskope. She's one of the original creators of RTMP, so this is really exciting. And she's also leading where RTMP is going to go from here, which is always a hot topic right now. Thanks for joining us, Sarah. This is really great.
It's great to be here.
She also, if you were at Demuxed 2019, she somehow managed to give a historical lesson in a 10-minute slot because she was one of the late additions to the schedule. Unfortunately, we didn't meet until after the talk selection, but it was too good not to have on the schedule. So she was gracious enough to squeeze in the space we had. So thank you for that. That was awesome.
Yeah, and there were so many stories I didn't get to tell, so I'm excited to come back.
So yeah, I think it'd be a great place to start with just a history lesson of RTMP and 1999, what was it like before y'all started thinking about RTMP? Set the stage a little bit.
So in the late 90s, the way that you did video on the internet was either QuickTime or Real Player. And people would come to a page and it would be, if the neither plugin was detected, it would be click here to download Real Player, click here to download QuickTime. And Flash was ubiquitous. It was, something like 98% of browsers on the internet. That was huge. There were hundreds of millions of people on the internet. So that was considered huge in the day. Now, of course, it's most of the people in the world. But in that era, it was a time when regular folks were using the web. Whereas 5 years before that, it was for academics and techies. Mm-hmm. And not even all the techies. So I was still working on the Director team. Director was working on its 3D thing. And
sorry, what was Director?
So the first Shockwave was made for Director. And so the Shockwave player was one of the first Netscape plugins, and we worked with Netscape when they were pre-beta to build that Netscape plugin, and it was also one of the first ActiveX controls. And then Macromedia decided that its internet brand would be Shockwave. And they confused everybody by naming all the players Shockwave. So Flash was originally acquired as Future Splash, and so they were required to call their files Shockwave Flash. And so the Swift file was originally Shockwave Flash, and then later they re-acronymed it to Small Web File.
I don't even know that version.
Because then, everybody was confused, and so we separated the brands, but it was impossible to disentangle. So I was originally on the Director Shockwave team, and so we were doing multi-party communication for like more of the gaming market with the Shockwave multi-user server that did UDP for fast communication. And that's when I really learned about like how firewalls are difficult. Not that they're actually difficult to configure, but that it's difficult to get the masses of the real world people to configure them. So the other thing, so Jonathan Gay had taken a year off to think about what's next. And he came back talking about this idea of doing two-way audio video in Flash. And he said he wanted to do something more exciting than X10 cameras. Do any of you remember the X10 cameras?
Vaguely.
No.
Yeah.
So the internet was blanketed with ads for these IP cameras.
Yes. Uh-huh.
And I looked it up. They were the first pop under ads. So when you opened a web page, behind it, the ad would pop up. So you would see it when you close the web page. And so people weren't as quick to dismiss it. And if you were browsing for a while, and this is before browsers had tabs, right? So you opened all these windows, you'd end up with like 7 different X10 ads under your windows that you would have to close. So it was a great exposure mechanism. Somebody did a study who was an internet service provider that X10 camera ads now account for 89% of bandwidth used by all broadband users.
Wow. So they X10 ads were the Netflix before it was cool. Who was Jonathan Gay? Can we, if we're gonna get it on the podcast, I think it would be helpful just like because he was a big deal.
Yeah. So Jonathan Gay wrote the first Flash player and was the primary architect of the player technology. And with Robert Satsumi, those were the two founders of Future Splash that were acquired by Macromedia. So that team grew to be about 5 people. And engineers working on primarily on the player and a little bit on the authoring tool. And Jonathan Gay was probably more famous at that time for having written Dark Castle and a number of early games when he was like, I think that's how he paid his way through college. And so I remember Gary Grossman, who added ActionScript, the JavaScript engine to Flash. Like he came because he wanted to work with the person who wrote Dark Castle.
That's pretty cool.
So the story I heard was that John came back and pitched the executives on this idea, and he had done some early prototyping and believed that we could do two-way audio video in less than 100K of code added to the Flash player. Because the Flash player was then 200K of code. So it was a big deal to increase the size by 50%. And at that time, the internet was exploding, right? So this was before the bust at the time that everybody signed off on this. And so they were really looking for places to invest. And so whoever was CTO at the time told him that he could pick any 5 engineers at Macromedia. And afterwards, I heard that the same executive was like, oh, I didn't think you were going to pick those 5. Because they were all like, each of us were people who could lead a whole team. Yet we got a chance to actually build the original version of the two-way audio video client and server. And so that was pretty fun.
200K, that's like just like your standard JavaScript framework these days, right?
Yeah. It's my joke is that engineers these days can't count that small.
Yeah. Yeah, well, in 2000, a lot of the population was still on modems at that time, I feel like.
Yeah, so we had to make stuff work on 14.4 modems. And like I remember at that time, I couldn't get DSL at home. I had to get ISDN. So that was like as high bandwidth as was available in the Mission in the 90s. And there were only 2 browsers, right? There was Netscape, which had the plugin interface, and IE that had ActiveX controls. And, we made it work on Mac and Windows for the client side. And, I don't know if you all remember the PowerPC was like one of the requirements. And the other thing that happened in the late 90s is that they published the Swift file format. So we went into this project with the assumption that we were going to open the protocol. And in fact, while I was still there, we documented the protocol in great detail, and the codecs that we licensed, we required them to give us all the information and allow us to make that public. So fast forward 20 years, when I came back and actually looked at the specification, I was like, oh, wow, 2012, what the heck happened?
This one can go backwards, but the X10 webcam reminded me of, this is probably right around that time. I remember we bought a scanner or something at my house, and it came with a rebate for a webcam. And I was so excited because I was going to get, this was back in the day when like a webcam meant that you had a camera somewhere that would upload like a JPEG to some FTP server every 30 seconds. And that was like your live webcam. And I was very excited about setting one of these up. And so I get this free webcam from this rebate, very excitedly plug it into my computer. And the quality was so low that you couldn't even make out my face sitting directly in front of the monitor. So needless to say, I did not get matte cam, which in retrospect is probably a good idea for like 13-year-old me to not have matte cam. So was anybody else doing anything like that? I mean, so when you're talking about adding this two-way communication into this plugin, like was there competition out there? Like what did that landscape look
like?
So
I think part of the reason that, like I synced up with John Gay and recently, and he said that part of the reason that it had to be two-way audio video is because we felt like the one-way world was really crowded, right? With QuickTime, Windows Media Server and Reel. And so there was WebEx existed, but everything required a download, and it was all very purpose-built. It wasn't a platform. There were some collaboration platforms, but there were more around document sharing and chat, and less around the video were purely video conferencing things, and there weren't that many of them that weren't dedicated install systems.
So when you were working on this for the first time, did Flash even have the ability to play back video then?
I don't think so, no.
Oh, okay. So
people would fake it by having like a series of images.
Right. So the impetus for actually Flash supporting video, which turned out to be this massive thing, was actually two-way communications on day one. It wasn't actually that Flash could play video.
Exactly.
Huh.
That's fascinating.
And I mean, I think for a long time, I felt like it was this kind of like, because during the development of this, like the internet started imploding and people started for the first time in a while being worried about revenue and stuff, right? And so for a while, I felt like it was this sort of close-kept secret that if we do two-way, we will get one-way to happen, right? Like it's sort of intuitive to me that one-way is half of two-way. Like there's a little more features with the buffering stuff, but we added that in air quotes totally at the end because I felt like partly I didn't talk about it because I thought we would lose the opportunity to do the two-way stuff.
Right.
If they would be like, okay, well, let's focus on one-way. And then we wouldn't have been able to release such a groundbreaking platform because it's so much harder to add interactivity later.
Right. So this entire platform that basically became how the standard way of viewing video on the internet for years was kind of like backdoored into a like video chat.
Well, yes and no, because the other thing that happened in the late 90s was DVRs. So TiVo had come out in the last year or two, and then there started to be competitors. And so we wanted to mix live and video on demand. So there could be a live cast that was recording, and you could join late and go backwards in time. And so we're like, well, if the DVRs can do it, we can do it. It's just bits. But that was revolutionary. And it's still, people will say, well, you should have different architectures for live and video on demand. And certainly if you know that you are never going to do interactivity and never going to do live, it's simpler to do stuff. There's all sorts of shortcuts you can take. But it's so hard to retrofit anything that is timely. And I think that's what we're seeing in the industry is that we've seen a lot of improvements to infrastructure that favor things happening reliably yet with high latency. Because, you can give up latency and get other forms of quality and certainly make the engineering easier.
It's funny watching us. I think we've actually talked about this on the podcast before, but it's been kind of funny watching the video community go full circle for stateful connections for video, right? It was like RTMP. RTMP is painful because you have to maintain a stateful connection to every viewer. Okay, we'll use streaming over HTTP. And then that was kind of the de facto standard. And then it was just like, but what if we started delivering things over WebSockets? And what if we started delivering things over WebRTC to try to like reduce that latency again? And now we're like fully back into maintaining a stateful connection with every viewer. It's really interesting to watch that like internet eating itself again. So
yeah. So it was also like this era where we were going from, in the early 90s, it was common to write a specification and then build your code and you have development cycles that were a year and a half. And not a lot of iteration, right? To the sort of precursors of Agile. There were definitely people doing Agile, even though I didn't know those words then. And there was this whole process at Macromedia about getting the specifications signed off early, and then you would do iteration during the development. But the spec kicked things off. And that was a challenge because the execs wanted to see our progress in terms of had we written these specifications. And we wanted to get it to actually work before we specified the interfaces, right? Because the interfaces would change depending on, the characteristics of the platform. And so I made up a new process that I called GLIDE, which was goal-led iterative development, the small e at the end. And so for every feature, we had a goal. And after you met that goal with a prototype, then you wrote the specification. And so that way they could see progress while the engineers could actually build stuff that worked. And those are the kinds of hacks that we had to do to get this thing to happen in a different way, because it was hard to make it work, into a video.
It's kind of one of those amazingly obvious in retrospect things that you should figure out how to make it work before you write down how it works.
You would think so.
You basically had to invent lean startup in order to get this done.
A lot of the stuff that was happening in the late 90s on the web is sort of analogous to what's happened in the last 5 years with web apps, where building it is not the hard part. Figuring out what to build is the hard part. There were a lot of applications where you just were well, let's decide what we're doing, and then the engineering is clear. But this was not one of them.
Well, so, we've talked about kind of what the landscape looked for internally here, but were other people doing this? When you're talking about all of these development cycles and getting things out the door, were you racing against anybody else? Was there a video race, or did you know about it, or what'd that look like?
We didn't know about anybody who was working on anything similar. And then I was surprised, sort of 6 months into it, when we were really struggling to get the low latency video and and achieve with the codecs, 10 or 12 frames per second were some of our early codecs that I was that's barely video. Then I walk in one morning, and on the interwebs is a press release from Yahoo that Yahoo Messenger 5.0 has video in Yahoo Messenger. And I'm like, oh, they totally scooped us. And I download it, and it turns out that the video is the thumbnail of the avatar. So it's 64 by 64 or 32 by 32 pixels. And it's 1 frame per second. And I was like, oh, I didn't know we could call it video at 1 frame per second. We could have totally released something. Well, I'm glad we waited to make it great.
Right.
And they didn't totally scoop us because that didn't really catch on.
Do you know which codec they were using, or which codec you guys were using with some of these early?
Well, we used. I actually did the codec negotiations with Isaac Babs, and
Who's Isaac Babs?
Oh, Isaac Babs was a biz dev guy at Macromedia, and so he actually. So people don't realize that even though the web had been around for 5 years, not many things were on the web, right? So how do you find a company that makes codecs? You can't do a web search.
Right.
You have to talk to people and, figure out who makes codecs. So Isaac did that. He went and found the different codec manufacturers. And, he found Nellie Moser, who this awesome group of audio engineers who made a codec for us.
Did he look them up in Yellow Pages or something? How does that work?
I think
Before the internet.
You start to talk to people who have codec needs, and they introduce you to other people who do codecs. And so most of the codecs we look at were just the codec was bigger than 100K of code compressed, right? And the audio codecs were crazy large. Oh, this one's, 1.2 megabytes. And okay, next. And so the way that we got the audio codec, we already had MP3 decompression in Flash so that you could play music. So it did, there was Shockwave Audio that implemented MP3 that added it to all its shockwaves in 97, I think. So we decided to do a voice-only codec, which could get it really, really small. And so they made a codec specifically for us that balanced making voice good with code size. And they were great to work with. Although the reason I'm I have a clear memory of this specification is because we had to write down the codec format, which was very hard, right? Like, we ended up writing something down, but it was like very, well, in theory, somebody could replicate that. But there was discussions at that point of open sourcing the Flash player, right? Like, it was like this whole openness win thing that was at one point seemed to be where things were going. And on the video side, we really wanted to use H.264, which is out then, but they hadn't figured out the licensing terms.
This was 2000?
This was by 2001.
Yeah, okay. Because the first codec that was in Flash was Spark, which was
It was 263, yeah.
Yeah, okay.
So we evaluated 264.
Oh, okay.
And they hadn't figured out the licensing terms, but we were going to put the codecs in the player, and we couldn't afford to pay per Flash player.
Oof. Yeah, that makes sense.
And so if we had put it in the player, Macromedia would have had to pay for every download. So we went with H.263, and I've read people criticizing it being non-standard. And there were two big differences. One is most people don't know that H.263 and similar family of codecs were written for when you had dedicated systems, right? And you had video monitors that were specific sizes. And so the 263 specification says you must support only these widths and heights of video. So we were like, well, can we put other numbers in there? Okay, no problem. That's non-standard.
Right.
And, I remember John saying, well, maybe people will want to make portrait video. Maybe shouldn't all be 3x4 because we'll be doing video conferencing. And people were like, oh, you think, really? And now the iPhone lets you do that.
We still don't want to do that. Still wrong.
Well, if you're compositing it with something, it could be great. So, and then the other thing that was non-standard about the codec is that they had constant bandwidth, which meant the quality changed over time. And when you're doing it over the internet, it actually, especially if you want to be downloading multimedia assets too, there's no reason to artificially have it constant. So we made another option for constant quality. Otherwise, you had this sort of throbbing visual effect.
It's amazing how things change and yet how they stay exactly the same. Now we're in 2020 and we're still angsting over what video codecs we can actually use on the web and who's paying the H.264 license and how to actually get good video delivered without that quality pulsating on keyframes. It's like the more things change, the more everything stays the same.
Well, I think that we're still chasing the, CPUs have gotten so fast. We have so much memory. And then we want to just gobble it up with
JavaScript.
bigger, more JavaScript, bigger screens.
It's kind of amazing. You mentioned earlier trying to get it right. And I think one of the things that attests to that is we're still using RTMP today. It's still a relevant protocol for some of the biggest sites on the modern internet.
I remember Chris Hawk was a PM at Macromedia, at Adobe now. Sorry, I will make that slip sometimes. So we worked together at Macromedia back in the day. He was one of the original PMs who launched the product and stayed for a few years and then left and came back. And so he came up with this idea of spinning out the technology to Veriskope. And when he first talked to me about it, I was like, are you kidding me? Because I just assumed it was a dying technology that nobody was using anymore, and I don't want to take over this dead thing. And then I started looking into it, and I was like, wow, YouTube, Twitch, Facebook, Mux, all these companies using it for ingest. And then there's all these different applications that are off the web. We think about the desktop web and the mobile web being everything, but it's also being used in apps, for some of the things that it was made for. But the majority use cases are oh yeah, that's what I use for ingest. And then started really learning about there's, the technology is applicable to a whole bunch of different things today because it's, it's just a really nice scalable server that it was built to run on a small footprint. So you could run it on a Raspberry Pi today. And most of the stuff that people are building for the desktop and mobile web is too heavyweight to put on little devices.
Don't we have an 8th Street cam that's on a Raspberry Pi that's streaming?
We do. I'm not sure that's on the public internet, though. I'm not sure anyone wants to look at 8th Street, San Francisco. But I think that's a really interesting point. Modern tech, if we put air quotes around modern peer-to-peer video technologies like WebRTC, only just now are people actually trying to build embeddable libraries. There's a recent C implementation of WebRTC that came out of a project called Pion that was a Go implementation of WebRTC. But just having multiple working implementations of WebRTC that weren't just the Google libWebRTC has taken years and years. And even now, they're not fully production ready. If you wanted to do WebRTC from an embedded device, it is really complicated to get that technology working. Whereas with the RTMP spec and a couple weekends, you can get something working.
Yeah. Well, I think one of the things that's really fascinating is like how many different libraries there are and different, like you're like, oh, if you want to have like there's an Nginx plugin and there's like this, if you want to have a standalone thing, here's a open source C RTMP server and there's like libRTMP and there's like RTMP implementation and multiple ones in most languages.
Red 5 in Java.
Exactly. And I think bigger than that is the tooling. Like when I was like starting to look at again and didn't recall all the details of the protocol, I can just use Wireshark and it's got built-in RTMP support. So that like having that ecosystem of tools is like very awesome.
So correct me if I'm wrong here. So when we're talking about like sitting down with these specs and trying to implement these things a couple weekends with RTMP, a constant thing that I've heard is like RTMP was reverse engineered to be an open spec, or it wasn't like officially an open spec. It's just a bunch of people reverse engineered the protocol. And that's one of the reasons why it became kind of painful to work with for so long, is because there's all these different implementations, because people would just kind of like, without the spec, they would just kind of shove things in. Y'all correct me if I'm wrong, but that I feel like that's something I've heard. Like, is that a thing? And is like, where is that today?
That's a great question. And many of the implementations, the most widely used ones, were released before there was a specification. So they could only reverse engineer it. And then in 2012, Adobe released a specification. And I've been looking at, the future, the direction of this protocol. And so we now have a microsite, rtmp.veriskope.com, where you can see the Adobe specification we've transformed into HTML backed by Markdown. And so you could go there in GitHub and make corrections and clarifications. And I'm in a phase now where we're first making some clarifications to the specification. And I've got a little side project where I'm trying to do like it's not really a clean room implementation because like I know the specification and I've seen a lot of the code that implements it, but I'm trying to write code just using the spec, and it's really hard. And what I found is all the information is in there. And so far I haven't found something that is clearly wrong, yet you have to look at 4 or 5 different sections and put them together and try to understand what these all are. And, often they'll say, oh, the ID, blah, blah, blah. And there's like chunk IDs and stream IDs and command IDs. And so it was probably just, I would guess, given to an engineer to write, and they didn't have the cycles to have a detailed review process. So I have great empathy for whoever needed to write this spec. It was like somebody, like a long time after the original team, and it wasn't somebody who was on the original team who was then tasked with writing the specification. But I'm excited to like actually put together some more easy to follow details. And RTMP-S was never specified. So there are different implementations of RTMP-S out there, which are it's really straightforward. There's the HTTPS layer, which works through all the firewalls, right? And then there's just over a secure socket. So it's, quote, simple, but it's also hard if you don't know that. Like, oh, there's 2 variants, and do I have software that speaks both? So just writing that stuff down, I think, will be a big service to the community. And
Step one.
I think that part of the thing that was missing from the spec, and what I've been following on a little bit with the work you've been doing on the spec, one of the things that's really nice is just getting some of the clarifications, like do this, don't do this. When I was working at Twitch, one of the things we kept running into was we'd read the spec, we'd kind of understand the protocol, and if you're a protocol nerd, there's things like the chunk stream, which then provides data for a higher level notion of stream. So there's this lower level and higher level. Things can be interleaved so that you can send a video frame over multiple packets interleaved with audio. But then you run into questions like, can I get a message from a stream on a new chunk stream ID? And you make decisions there because that's a little bit unspecified. And the moment you make a decision there, you're going to find an encoder that made the different decision. So people have ended up having to write RTMP servers that are extremely, extremely forgiving for what's actually out in the wild. But then one of the actual things that caused a lot of issues, in my view, is there were kind of two camps working on RTMP. There was the camp that wanted to build in interoperability and actually build RTMP-powered apps and understand the spec and work with it in an open source manner. And then there were stream pirates. So I think the difficulty that came around working with RTMP was RTMP-E, that notion that there's an encrypted stream that has some DRM built in, that was extremely sensitive at Adobe. And I think that polluted the conversation a lot because half the people using RTMP just wanted to steal content.
I think that's a good point. Like, I think a big part of it is the clarification of intent, right? So if, it's 2020 hindsight, right? Great empathy with people who were in the trenches making these decisions because it's easy to say things in retrospect. But I think that, and like what I'm trying to do now is really that like, well, let's communicate what Adobe/Veriskope wants, right? The DRM stuff is secret and private, and you have to get it from Adobe and whatnot. But I think that got muddied where it wasn't clear to the community what, there was some threatened litigation and stuff like that, which then I think made a lot of people just kind of want to back off. When actually the majority of RTMP was not in contention, right? Had been documented and so forth. And so just teasing that apart for the community. And then I think, as people are more and more security minded, making sure that we have the security laid out and people can implement that without fear of reprisal.
Right.
Because I think, people will always want DRM solutions, and those can be layered on top of, an open protocol. And I think that's what, kind of needs to be clarified. And I think it would have served the community if that had been done earlier, but here we go.
Yeah, that's something that Facebook has recently switched over to enforcing RTMPS only, or they're moving in that direction for new streams. And it really is that difference between, as an individual broadcasting some content, you want to make sure that the person on your Wi-Fi or the NSA can't intercept your stream and watch it. And that's a completely different requirement from DRM, where you are sending the same video to multiple viewers and you want to have some kind of encryption mechanism that prevents them from just like sharing that content and capturing that content. So yeah, I'm very excited to get the clarifications coming from that sort of Twitch background, having worked on RTMP ingest at Zencoder, now Mux. Yeah, it's very exciting to actually have a spec that's getting annotated, have some of these details fleshed out, and to know exactly how we should be building that security into our product.
Yeah, and I think the other aspect that I think will become important is who is broadcasting, right? So the other reason, it's not just that somebody can intercept and see your private feed, although that can be an issue if you're doing it for a private group, but somebody could pretend to be you. And, we have a lot of confidence that I think is false confidence that when we see somebody in live video that they are who they are. But actually, I did After Effects early in my career, I well know that we can fake these things, right? We can fake what we look like. And so I think as time goes on, people will be wanting to have end-to-end security so that the video, the video originated with me if it's coming from my stream.
It's really deep fakes is an increasing, it was a problem before. I think people are more scared about it now because of the publicity that deepfakes have gotten recently, but that's a really good point.
Yeah, I think that the more that, kind of like with HTTPS, I've been following, HTTPS did not become widely adopted because anybody regulated it or did some kind of top-down, everyone must use HTTPS. A lot of the engineers have conspired with each other to make it more and more obvious to consumers that if they're not using HTTPS, it's a bad thing, right? First was just okay, let's put up icons and, let's spread awareness about what's safe and what's not. And then okay, let's make it you have to click a few things before you get through to the non-HTTPS website. And I think that style of introducing security by first introducing the secure features as an option and then gradually making it seem more difficult and scary to do the non-secure things before you take it away. I think that's a way that we can introduce these concepts. And if we get people creating things that have some kind of authenticity stamp, then I think it's the only way that I think we can really solve the like fake news, deepfake thing, by actually having some record of the originator of this videos and how it's been mashed up in between.
Slightly different topic. I'm interested to know where you feel like the topic of adaptive streaming is going in relation to RTMP. Like when I'm talking to people about WebRTC specifically, like there's a lot of questions around how WebRTC does adaptive streaming, because it does actually aggressively downgrade the quality in order to maintain that real-timeness of the stream. Most people using WebRTC, I rarely see it go above like 540p video because it's, again, trying to keep that, real-timeness. And then there's a detail of, with WebRTC, when it is doing adaptive streaming, it's usually creating all of the different versions on the client as opposed to doing it on the server. And so like when I'm talking to people about WebRTC versus using RTMP, like some of the things that come up are, RTMP is everywhere and it like actually more likely will maintain the quality that you're trying to go to because it doesn't have all these, call them protections against dropping from real time. Just wondering your opinion on where that technology is at, where it's going with RTMP, that type of...
Yeah, so like, and just to sort of context set, at the beginning, we only had one codec. Mm-hmm. And that made things easier and more complicated, right? Because it was a limited set of tools. But we would drop frames, right? And prioritize audio. Because it turns out that if you aren't seeing everything, then it's like less critical than if you hear. If voice gets behind or you miss something and you get a pop, like, it's really, really bad. Mm-hmm. And people are much more forgiving of something visually missing data. Mm-hmm. And what I believe is true is, but it would be interesting if there's been any studies in this area, that when it comes to video conferencing, the quality of the video is probably more important than seeing every little detail of movement. So the other thing that's interesting about video conferencing and compression is that most people keep their heads still and there's very little motion. So you can actually get the streams to be very small, if it's set up well and you have that type of video conferencing. Of course, movies are a different thing. Mm-hmm. Back to your question, in terms of where things are going, I think that if your target is desktop video conferencing, compressing multiple streams on the client is absolutely the right choice, right? Because you have enormous compute power on the client. You have no transcoding, right? Because transcoding increases latency. It has to. And so if you can match all the clients with the same codec and the same, and something that's generated by one of the clients, like you're going to have the best latency. So that's great. It's challenging because then sometimes the clients aren't as high powered and you have to make trade-offs there. Like, I want to move to this new codec that is great bandwidth, but it's hard to generate multiple streams on multiple clients. So having a solution where you can, make a good guess, right, that one of the clients produces and then have a transcode on the server makes a lot of sense. When you can support it, supporting multiple codecs for multiple bit rates from the clients is going to give you the best quality. And so I think the other thing that's interesting about WebRTC, and I haven't dove into to see what codec, how exactly it's implemented these days, but from a specification perspective, it allows lossy transport, right, for the video and audio streams. And so you could potentially take great advantage of that from a codec if the codec is built to support lossiness. Practically, that's very hard to achieve because there's certain things you need to have. And knowing what's necessary and not necessary is super challenging, right? That's why we're still inventing codecs in this millennium. But I think that one of the areas that I'm really excited at looking at is the QUIC protocol, because it allows for lossy and lossless streams over the same connection. And so QUIC is what is the foundation of HTTP3. And so that's going through a standards process because there was an original QUIC and now this has been modified and actually so that it will support all of HTTP and then it will become the HTTP3 protocol. And so I think that has the promise of, one, the characteristics of the protocol are something that would actually work well for audio and video streaming. And I think that I'm really excited to like look at layering RTMP on top of Quick. And I'm also looking at, frankly, layering RTMP on top of WebRTC. Like that could work in terms of like having the semantics of RTMP and just the transport of WebRTC could work well. But maybe we can leapfrog it and get, maybe if Quick is out early enough, that might be more suitable because it's really built for two-way streaming.
I think there's also a question there about new codecs that are built for example, lossiness or even better compression. One of the challenges, or perhaps one of the features of RTMP has been that static list of codecs, right? There's a set list of things you might encounter in an RTMP stream, and there's absolutely no way to add in a new codec to that list. Is that something you're thinking about changing as part of this spec?
That's a great question. So it was by design to have very few set of codecs because that makes it simple to implement. And it also, we were worried about the code size of the client. So this, I think, has been a success in creating the interoperability. Yet some of the codecs are awesome. I don't think I ever anticipated 8K video. When we did After Effects in 1990, 4K was film quality. And so I thought 4K was the max that we would ever do for video. And it turns out, well, we can do more and understand how humans see video. And then VR is coming up, which is even fatter than that, right? And so you really start to need the, better codecs in order to deliver good experiences. So definitely looking at expanding that list. And I've had some healthy debate and would love to talk to anybody about whether we should have an escape hatch for somebody to specify their own codec, which is a well-trodden debate. But I think that it would be healthy to have that again, because as soon as you allow anybody to specify anything, then that affects the interoperability negatively. But there will be a time, 10 years from now, there'll be codecs where I can't believe we're using such old, yucky codecs. Our new, best thing is going to not be awesome 10 years from now, or maybe even sooner. So we started a RTMP channel on the Video Dev Slack. And so would welcome people who want to come and bike shed about protocol decisions. What I'm searching for is really great use cases, right? I want to always make decisions with, and this is why, and this is how it's going to not just help a particular vendor, but really be the right thing for the community. And I think that the exciting thing about being situated with Veriskope, which has gotten the assets from Adobe, is that I have, the authority to write this new specification. And my goal is to just do some short-term things first that will address pain points in the community, the codecs. And we've heard from people running big services that having a redirect in the middle of a stream, which clients would respond to. Because when you first connect, it can say go somewhere else. But then if you're in the middle of live streaming and you need to drain a server, there is a,
That would be cool.
So that I think is really straightforward to add. It's just a matter of, sort of figuring out the right sort of syntax for it and where to put it in the communication. So relatively small things, I think, could fit into having something kind of like a 1.1 spec that would be where I think all the server people who are running services would embrace being backwards compatible. But then if a client were to advertise that it supports 1.1, then the server could take advantage of 1.1 features. And I think Veriskope's well positioned because I think that we're the only company that has both client and server technologies, because we have the RTMP SDK too. I think there might be some companies that have, but I don't know if they have client SDKs. But in any case, we have a lot of people who use the client SDK, and so we have a kind of footprint there. And then we have a server that we sell, which doesn't compete with the big services, right? So some people want to buy a server, and that's a different thing. So I think it's neat to be situated at Veriskope and helping take this forward from a position where we're not competing with most of the people who need the spec changes.
We've already started dabbling in this about where things are going, but is there anything else in your mind? What else is, we're talking a little bit right now about 1.1, but what do you see in 2.0? If you were going to cut a 2.0 in the next 5 years, what do you think that looks like?
Well, to wrap up the 1.1 thing, the other thing that is it's actually independent of any protocol release, which is formalizing how data is sent around. Because there are, closed caption specifications, there are ad insertion specifications, but how those get put into streams and on the wire could be a bunch of different ways. And so it turns out that there's a bunch of arbitrarily different things across the interwebs for common data interoperability things. So I think having those specifying how multi-track audio works, which is a capability of the protocol, but somehow like a limitation of certain parts of the ecosystem that I'm still trying to figure out. So I think those are kind of addressing the near-term pain points. And then in the future, I'm super excited to see whether Quick will give us the transport that we need. And if we can manage to really like dive into it before they like sort of ink the protocol. It's not just the protocol, it's the implementation. So what I've seen historically is that like some standard comes out and then it doesn't really matter what the standard says because the implementations don't work, right? Like that happened with CSS initially, right? Like it was just super hard to use CSS until like 5 years after the standard came out because, there were browsers that just didn't fully implement the spec. And so if we can kind of like get into it before the standard gets rolled out completely, then I think there's a chance it could work really well. Because bidirectional streaming is not really, it's an incredibly common use case. But if you are somebody who's used to thinking about how I download documents and display HTML pages, it's an edge case, right? And there are probably more people doing bidirectional communication on the internet than there were people on the internet in 2002.
Right.
But if there aren't companies really using these new protocols for these use cases, then they're going to end up not really working. Like I remember I was an executive that I won't name in the 90s at Macromedia who said, why do we have to be involved with standards? We weren't involved in the CD-ROM standards when we did, in interactive multimedia. And that worked out fine. And it sort of felt wrong to me. And like I thought about it and I was like, yeah, that's why CD-ROMs don't work well for interactivity. Like we always had to do this like crazy amount of like, let's keep stuff in memory because the seeks were really slow. And like, that's what happens is that like by default, what happens for video is VCR controls. And the level of interactivity that anybody has is VCR controls. And so if you want to have better than that, like, we have to actually exercise the protocol. So I would like to see, a kind of platform on the web that's based on open protocols that allows for the type of interactivity that Doug Engelbart was doing in the 60s.
And so something that would power some of these interactions, relatively newer interactions, like people chatting alongside Twitch stream or HQ trivia and things like that. Is that kind of what you're talking about with this interactivity between video streams and?
So that is one kind of interactivity. That's not really what I was talking about.
Okay.
I was talking about like the ability to actually do like linking across videos, say. Like, so imagine that this podcast was a video and I had slides of the timeline of RTMP and somebody's watching this and they could click on that timeline and then go to, a 30-minute video about the history of the internet at that time, right? This is what we envisioned in the early 90s, right? Interactive television was going to be like. And it's just never been a thing for reasons. But I guess that could be a whole nother podcast. Why did ITV not happen? But I think that now we have the platform for ITV, right? That people were trying to create with dedicated hardware and software in the early 90s. And now it's the internet. And we have these notions of linking and having additional information to augment our stuff on the web in text and graphics, right? That does not happen in video. And there are some nice implementations of it. I have to say, the X-ray stuff that Amazon Prime does, right? There's some sweet stuff that is being done, but it is incredibly fancy engineering. And I think in the future, it should be as easy as, marking up an, HTML page to do many of those things in video. And people have been trying to do this for since before I was born.
I think at the very least, building in that kind of flexibility into new protocols and like getting in, like you're saying, getting involved with Quick, put somebody in the room who's saying, what about the data going the other way? How do we keep that fast? At the very least, even if it's not one specific product that wins, it opens up an ecosystem where people can actually imagine whole new things and then have the tools to go build them, not be held back by, oh, this protocol is actually only good for one-way data, or, oh, you can't really mix different media types over these connections. And yeah, that's an interesting sort of notion there of being in the room so that those things at least become possibilities.
Cool.
I think one last request is please, can we have Opus, maybe AV1? H.265 can come too, I guess.
Parting words from Nick.
Duly noted.
Wasn't a yes.
I won't pre-announce the details of our not yet fully designed protocol.
Well, I will try and get involved in that room.
Excellent.
And one of those rooms that Sarah mentioned was RTMP on video dev. If you're not familiar, that's a Slack organization full of smart people that work with video every day. So that's video-dev.org. There's also a link on Demuxed.com. I think it's in the footer and the header. And I think if you just go there and search dev, you'll find it. On that note, the other big news, we officially, as of this morning, have signed the contract with the venue for 2020. In San Francisco. So that's going to be October 7th and 8th at the SVN West in San Francisco. So right off the BART lines. So we're not in deep dog patch.
Ooh, fancy new digs.
Fancy new digs. It's pretty sweet. I'm really excited about it. I'm not going to lie. But yeah, it's October 7th and 8th. Book it on your calendars. This is the first time I'm officially publicly announcing it. But by the time this is actually published, it'll probably already be out there in the wild. So you retroactively heard it here first.
We heard it here.
Y'all heard it here first. So anyway, thank you so much again, Sarah. It's an honor to get to chat with you about this today.
It's a pleasure to be here. Thank you.
That's all we have for today. But as always, we'd love to hear what you thought, even if you disagree. So please reach out on Twitter at Demuxed.
To learn more about Heavybit, visit heavybit.com. And while you're there, be sure to check out their library. It's packed with amazing talks on sales, marketing, product, and general management from founders of developer tools companies and other industry leaders.